Hey, welcome back to the lake. What I'm going to show you today is how to check and service, potentially repair your heating and cooling system on your houseboat. These houseboats have residential style heating and cooling units. They're identical to the ones you have at your house. So this repair video will also show you how to check and service the units you have at your home. So I'll give you a basic run around of the outdoor unit and then we'll move inside. Let's get started. I considered making a basic and an advanced version of this video, but I've decided to put them all into one space. Please don't take on a task that you're not comfortable and able to do. If one of these procedures is out of your comfort zone, please call a professional. Okay, this is the outdoor unit. This is actually a heat pump. It's about a 2004 model, so it's got some age on it. It's in pretty decent shape. It works well. It's got a few issues, but what we're going to do is I'm going to clean the condenser and check the controls on it. I'll show you how to check the contactor, the capacitor, all of the wiring in the outdoor unit. But first we're going to go inside and we're going to turn off the power supply. Okay, the power supply in my boat is actually located down below in the hatch. Some of the boats I've seen, this is a lake view, but some of them have a panel and breaker system up on the top side, but mine is below. So I'll take you down below and show you what my panel looks like. Okay, here's my panel. So I'm going to open it up. It's just like what you would see in your house. It's labeled heating and air conditioning, one for the outdoor unit and one for the indoor air handler section. So let's go back outside. Okay, let's take a look at my heat pump here. It's kind of tucked in the corner, and the access panel to the controls is right here. And as you can see, it's a challenge to get to the screws because of the way the canvas goes around the boat, and actually missing the screw on that corner. There's only 2 screws and one of them is missing. So I've got 1 screw to take out, and then I've got to remove that panel. So I'll do that now. All right, I'm going to verify with my voltmeter that the power has been disconnected. I'm going to switch the meter to volts, AC, and then check the power. Now, if you don't have a voltmeter on your boat or around your house, it is a handy thing to keep around. They're not really super expensive. You can get one at Lowe's or Home Depot, and it could save your life or get you out of a bind. So let's check the power and make sure we're dead. Okay, power comes into this unit right here at the bottom. You can see the red and the black wire. Yours could be different. Yours could be 2 blacks. But they go into, this one feeds directly into the bottom of the contactor. That's the way most residential units are. So I'll check voltage, and power is off. All right, so there's the contactor. That is basically the on and off switch for the outdoor unit. The thermostat sends power to this little device and kicks this unit on and off based on the demand in the house. So what I'm looking for out here is bugs, animals, snakes, anything, burned wires, anything like that that could cause us issues. I see some spider webs over there. We have a lot of Japanese beetles and stink bugs. They like to colonize in here, and they can get into this little contact here, and when your air conditioner calls to kick on, that snaps down. And if there's one of those guys in there, it smashes them, and that causes the air conditioner to fail to start. So it's a good idea to just keep this cabinet cleaned out. Let me grab a brush and we'll just kind of dust it out here and remove all the cobwebs. All right, I'm going to use an old paintbrush I had laying around. No big deal. I'm just going to kind of knock all the spider webs, everything out of here. It doesn't look like the capacitor was secured back in place, but we'll fix that, no problem. Looks like every wire tie in here has been cut at some point. I'm ashamed to say that I haven't even checked my own unit out here, so this is my first time looking in here. So we'll kind of fix it up together. All right, this is the capacitor. This is probably one of the most common items that fails on a heat pump air conditioner. And this is a start capacitor. This is a run capacitor. This is a start capacitor. This only helps get the compressor started and running smoother and faster. This only stays in play for the first few seconds of the start. And this is usually not on most units. This is an add-on item. Some manufacturers will put one on the higher level, higher end units. They'll have them from the factory, but they'll be separate. They'll have a start capacitor and a separate relay, but the relay is built onto the top of this one. So what we're going to do is check the capacitor and see if it is weak or not. Okay, this is what we call a dual capacitor. It's 5 microfarads for the condenser fan on top and 35 microfarads for the compressor. So part of it runs the compressor and part of it runs the fan. So let's check. Usually they're labeled on top, fan, and then there'll be one section that says common over here on the yellow side, and then on this side it says hermetic. It says HERM. That means hermetic compressor. It's just kind of giving you an idea of where the terminals are. The colors can change on these. They're not, you know, Carrier stays the same throughout theirs. This is a Payne unit, so it's made by Carrier. But the colors can change. If you take these wires off, pay attention to where they go, because if you don't pay attention, you need to be able to read this wiring schematic to put them back. Alright, so I'm going to check the ratings on this capacitor, see how good it is. Okay, so I'm going to set my meter to read capacitance. Right up there, that is the symbol for capacitor. And I'm going to put 1 meter lead on the common and 1 on fan. I'm reading 4.6. It's rated at 5. I'm going to put 1 lead on common and 1 lead on hermetic. It's reading 24.4. So this is supposed to be reading 35. This capacitor is weak. This capacitor can be plus or minus 5%. So we are outside of the acceptable range. So this needs to be changed. Had I not found this, I would have been having air conditioning problems in the middle of summer, when probably on the hottest day. So I'm going to change this capacitor now. It is a brand new 35.5. So let's see. Let's double check the new capacitor to make sure that it is not weak from the factory. I have opened up a brand new box and had a bad capacitor. So let's check this one out. Going to find common right here. Fan is right here. And hermetic is right here. So common, fan, hermetic. Okay, so I'm going to put 1 meter lead on fan and 1 on common. And we are reading 5.1 microfarads. Now I'm going to switch to hermetic and common. We are reading 35.8. So this new capacitor is definitely good. Now let's get it installed. Okay, I was able to get the capacitor installed and the wires cleaned up a little bit. I realize this is not the greatest spot to film from. I'm on the right on the edge of my boat. There is a lake. If I drop a tool, it is gone. The sun is shining in the wrong direction, but hopefully you can make sense of what's going on here. This is a heat pump, so this is the defrost board. This is what controls the condenser fan and the defrost cycles. I'll go into that deeper in the fall when we do a fall service and winterization on the boat. I'll check out the heat cycle, check out the heat. So you can subscribe and I'll show you that in the fall. But we've got a brand new fresh capacitor that has been checked out. We put our hard start kit back in. By the way, the hard start kit plugs into the common terminal and the hermetic terminal, not the fan terminal. This is for your compressor, not your condenser fan motor. Okay, so also while you're in here, look for burnt wires, loose wires, anything that looks like it's been hot. This is the relay that turns your condenser fan on and off. So check the wires and the connections on that. Check the wires and connections on your contactor. These are good and tight, and there are no signs of heat. A loose electrical connection creates heat. So there's no sign of any heat or loose electrical connections. Everything's plugged in properly. So let's button this back up. Let's clean the condenser next. Okay, getting ready to clean the condenser. There are a couple of different styles. This one has the open fins that you can easily see. And they're very easy to clean and wash. Some of them will have guards over them to where you cannot see the fins, and they're nearly impossible to wash without moving a bunch of panels. Sometimes you can sneak in the side and do a little rinse, but sometimes you have to remove all the panels. Another option is taking the screws out, and you'll have to have a helper. I'm not going to do it on this unit because I'm right on the edge of the water. But take the screws out around the top. This top lifts off, and you'll have to roll it over. And you can rinse from the inside out. You just have to watch your wire going to your condenser fan motor, that you don't pull it too hard and pull the wires out of the capacitor or contactors or your relay boards. So it's best to have an extra set of hands, which I don't today. You could take the bolts out, the screws out on around the whole top, or you could just take these out here. There's just 4 of them. Lay it over and wash it that way. There's a couple different ways you can attack this, but the major thing you want to do is just rinse the condenser out. Remove any debris, leaves, grass, cottonwood, anything that has gathered on the condenser will affect the efficiency of its cooling capacity and its heating capacity in the wintertime. So I'm going to show you what I'm going to clean it with. Okay, since we're on the lake and we're going to be rinsing this directly into the lake water, I'm going to use Simple Green. It's a non-toxic, biodegradable degreaser cleaner. It's safe. You can read the label on it and make your own decisions, but this is what I'm going to use. It won't damage. It's not a real harsh cleaner. It won't damage the aluminum fins, and it won't damage the copper underneath of the fins. So I'm going to spray the condenser coil down with some Simple Green, and I'll rinse it out after that. Let's get it going. This is also another cleaner that you might be able to find locally at one of your supply houses. It's more of a professional type cleaner. It is also non-toxic, and it won't harm your condenser. So if you want to try to source something like this from a local supply house, I'm not sure if Lowe's or Home Depot would sell this, but this is more of a professional grade condenser cleaner if you would like to try to find something like that for your home. But for the lake, Simple Green is going to work for me just fine. Okay, we'll let that cleaner soak for about 10 minutes, and then we're going to rinse it off with a water hose. It's very important that when you're rinsing with a water hose, you use a very light stream. You don't want to use a pressure washer. You don't want to bend these fins over. A little bit of damage like this is okay. You don't need to worry about that. But if you have sections of your condenser that the kids have played and put their fingers in it and folded them all over, or someone has thrown a paddleboard or kayak paddles or something like that up against your condenser and it's folded over a large section of fins, you probably need to take the time, get a fin brush, and try to straighten them out. That really affects the capacity of the condenser to reject the heat into the outdoor air. That's what this thing does, is it absorbs the heat from inside and removes it to the outside. So let's let this soak for a few minutes, and then we'll get it cleaned up. Okay, the condenser is clean and has been gently rinsed. Let's take a look at the indoor section of the air conditioning unit. Okay, here is the indoor section, the air handler section of my heating and cooling unit. So I'm going to take the front cover off and we'll take a look inside. Okay, let's take a look and see what we've got here. You can tell by seeing the rust in the bottom of this unit that it has had some water backed up into it. And you can also see by the looks of the wood that it's been damp around this unit. And I'll tell you why. They did not have a P-trap on the drain. The drain had been brought directly out of the unit and straight into the condensate pump with no P-trap. And the reason you have to have a P-trap is because when this air handler is turned on, that line has suction on it. And the only time this unit would drain is when the unit would kick off and the fan would stop running. Then it would lose suction and it would dump gallons of water. So that is why this unit was overflowing. The second drain hole you see there that I have plugged off is the overflow drain hole. I didn't have enough PVC to finish the job. I had to piece this together with materials that I had on the boat. I typically wouldn't use blue PVC glue, but I used what I had available. When you put a rubber coupling on your drain line, that makes it easy for you to clean out when you do have a stopped up P-trap. Because it is quite common for a P-trap to stop up. In the wintertime, it gets completely dry where you don't have any condensation running through that line. So whatever trash, dust, dirt is in that P-trap will get dry and hard in the wintertime. And then when you add water in the spring, summertime, it backs up. So it's a good idea to remove your drain line, clean out your P-trap, or at least blow some air through it, pour some water through it to make sure it's clear and flowing. Okay, what we're going to do now is remove the lower section of the cover. That will expose the evaporator so we can check to make sure it is clean and there's no issues. Okay, this is on the return side of the evaporator. You can see a little bit of mildew-ish stuff growing on the evaporator. I'm going to get the simple green and we're going to rinse the evaporator off and make this perfectly clean again. I've seen these to where it looked like a rug was stuck on there. Sometimes you'll have to use like a light bristle brush to try to pick the rug off there. It's much easier to do when it's dry. If your evaporator is very, very dirty, you're probably going to have to call a professional. Not all evaporators are this easy to get to, but this one is relatively easy. Another thing we're going to look for is any oil. And if you notice, the water in the drain pan is beating up like it's been turtle waxed. When I purchased this boat, the unit had no refrigerant in it whatsoever. It was completely out of gas. This unit has a very rusty tube sheet, and it had a couple small pinhole unrepairable leaks in the tube sheet. This is an older unit that has R22 refrigerant in it. So what I did was I used a product called AC Easy Seal. It's kind of a last resort when you can't repair a leak and you don't want to replace the unit. It's kind of a Hail Mary. You can add that stuff and see if it works. I added it. This is going on my third summer and it has worked fine. So that's why there is an oily residue in the drain pan. I'm going to go ahead and clean the drain pan out really well. Pour some bleach solution water in there so it runs through my drain tube and into my condensate pump. You can also see the discoloration in the water in the condensate pump. You can get residue and build up in these pumps and they'll stop working. So it's good to flush them out with a light bleach solution and make sure everything's flowing and working properly. Okay, the evaporator is looking really good. The simple green did its job. It's nice and clean. on the end, this is the side the air comes into, and the air comes out of this side where the blower's at. So this is the side that gets dirty. It's really nice and clean. I don't have anything to worry about there. I've got good airflow. It will continue to rinse itself. As soon as I turn the unit back on, it'll start making condensation and draining. So now I'm going to rinse this drain pan out and we'll move on to something else. I'm going to go ahead and spray some simple green in the drain pan so I can clean all that oily residue out of there. That way if I have any future issues, I'll see the fresh oil, I won't be looking at old oil. Okay, the drain pan has been scrubbed out with simple green. So I'm going to dump some nice clean water into the drain pan and rinse it out. Kind of pour it in slowly. We'll hear it go through the drain pipe and into the condensate pump. We should hear the condensate pump kick on in just a second. It's flowing out nicely, so I don't have a backed up P-trap. If you can hear the pump pumping or not, it is working fine. I'm going to dump one more batch of water in there. So rinse it out just a little bit more. I ended up using simple green to clean out the drain pan. So I am not going to put a bleach solution into there and pump it through. I'm just going to use the simple green because it's a degreaser and it kills about everything. So I'm just going to cycle, I guess these are 2.5 quarts. So 5 quarts of water through the pump and we'll be done. We'll put the screws back together on that side and we'll be done. Okay, the evaporator section's all buttoned up. The drain is clean. The pump is working and been cycled and pumping properly. I'm going to check the capacitor here on the indoor blower motor just to make sure it's not weak now. Okay, I meant to tell you this earlier, but just because you have the power off, you can still, these capacitors hold a charge and you can still get a little bit of a shock out of them. So when you unplug them, before you test them, if you just take a piece of metal, screwdriver, or anything, and short across the tops like that, it discharges them so you're safe at that point in time. So I have set my meter to capacitance, if you can see that or not, and I'll read the top. This capacitor is reading 9.5. Okay, so this capacitor is rated for 10 microfarads plus or minus 6%. Okay, I've checked for loose electrical connections. I don't see any burnt wires, loose or chafed wires. So I'm going to, I don't like the way those are rubbing against that metal there. I don't know if you can see that or not, but there's a mark on that wire where it's been laying against that metal. That is terrible, the way they did that. Yeah, I was just inspecting that a little bit further. I'm going to pull those wires back and put some tape around them to protect them from the sharp edge so they don't chafe and rub against that. That would end up tripping a breaker. It could cause a lot of issues. So I'm going to fix that problem. Once again, you can see down there where the bottom of this unit has been wet. It's rusted all the way back there. But that problem has been resolved. It shouldn't continue to leak. So everything looks good in here. I'm going to tape this up and then I'm going to put the cover back on. Okay, cover has been reinstalled. I'm going to turn the breakers back on now. Okay, flip the indoor unit breaker back on, outdoor unit breaker back on. Okay, this is a Wi-Fi thermostat. I have it connected to the internet and I can control it from my phone at home. So while I'm away, I can keep tabs on the boat temperature, if the air conditioning's working, do we have a loss of power. I have the outdoor temperature sensor in my engine compartment, so I can tell what my engine compartment temperatures are in the wintertime. I can monitor the boat. I know if we have power outages. It just gives me a lot of options and abilities to keep tabs on the boat when I'm not here. So right now we're in a 5-minute time delay because we just turned the power back on. It says waiting for equipment. So as soon as the waiting for equipment time delay is over, the system will kick on. Okay, the system's back up and running. Check the pressures. Refrigerant charge is right on. So that AC Easy Seal has done its job yet again. Ready for another summer. Okay, another check you can do is take a temperature reading of your indoor air temperature, which would be your return air temperature. Put your temp probe in one of your supply vents. After your system has run for, let's just say, about 15 minutes, you should notice that you have somewhere around a 15 to 20 degree temperature differential. So let's say you have 74 degree air going in, you should have 54 degree air, 54 to 58 degree air coming out. So let's let it run for a little bit. I'm already down to 57 and the unit's only been running for less than 5 minutes. So my TD, my temperature drop, is looking pretty good. I'm over 20 degree TD right now. Let's let it run for a few minutes and see where it stabilizes out to be. So you need to check and change your air filters. This boat has two 14 by 20 air filters. They've just been changed. These are kind of some cheap filters that were on the boat when I bought it. I really need to pick up something better than this. I mean, these are nearly see-through. Very good quality. The metal part always goes in. You want the air sucking through, and the metal part on the downstream side of the wind. So you can see when I put the filter up there, it sucks it up into place. Okay, this boat has two filters. I'm going to check and change both filters right now. The other filter is located in one of the lower cuddy cabins. It's right next to, there's a bed. So you have to be careful, make sure the kids haven't been playing around and thrown a pillow up against the return air duct. This would cut your return air in half and potentially cause you to freeze the unit up. This is simulating a dirty or completely restricted filter. So keep your return airs unblocked with clean filters, and keep your supply airs open and unblocked, unrestricted. Okay, let's say I potentially had two dirty air filters. What would be the symptoms of having dirty air filters? I would have a lack of airflow. My outdoor unit would run low suction pressure, which could cause my evaporator to freeze up. I would start to see icing on the line at the outdoor unit, icing at the indoor unit at the evaporator. So it's very important to keep your filters clean and changed. Another reason your unit could be icing up is you're potentially low on refrigerant. If you've checked your filters, you don't have any blocked return air ducts, your evaporator is clean, then you're probably low on refrigerant. It's time to call a professional, have them come and check the superheat and subcooling on your system and get it charged back up to the proper amount. As you can see, my unit's been running for about 10 minutes, and I'm going to look at the suction and discharge lines, and as you can see, the suction line already has condensation. So that tells me that my refrigerant charge is pretty spot on. If I was seeing ice here, I would know I have a refrigerant problem for sure, because I know I have clean filters and I know I have a clean evaporator. I know there's no restrictions in my return duct. So if I had ice, I would be low on gas. If this line looked like this line and was just room temperature, I would be out of gas, or my compressor would not be running. It's possible for your outdoor fan to run, but the compressor to not be running. If you can't hear that hum down there, you only hear the fan running, that means your compressor's not running. you probably need to check your contactor or your capacitor. If it's not your contact or your capacitor, it could be a bad compressor or burnt wires at your compressor terminals. This is what the plug looks like that actually goes from your contactor and capacitor down to your compressor. This plugs directly into the compressor. Sometimes these can get a loose connection and melt. If you happen to remove the top when you're cleaning your condenser, reach down and double check the plug going into the compressor. Not all brands are designed the same. Some of them are just 3 wires with terminal ends that plug in, but most of the Copeland compressors have this style plug on them. Okay, it looks like my supply air temperature has settled out at about 51 degrees. Okay, and we have a 74 degree room temperature or return air temperature. So we are really looking good. We have a perfect TD. Temperature drop, that is. Well, I hope that answered some of your questions and maybe you learned a thing or two there. If you have any other questions that you would like for me to answer or make a video on, please comment down below. I'll do a follow-up video in the fall and we can cover the heat pump operations and the electric strip heat section. If you liked the video, please hit the subscribe button. Thanks so much.